you want to go ahead and introduce yourself, Dan?
Uh, sure. Um, so my name is Dan Finkel. I'm based in Seattle, Washington. So right now it's 9:30 p.m. for me. And actually it's fun because the next speaker we chatted yesterday, but she's coming in from Perth, Australia. So the opposite end of the world from me. Kind of a neat thing. I'm the founder of a an organization called Math for Love, mathforlove.com. Though I suppose in different parts of the world we go by Maths for Love, um, and we're really just devoted to changing how people learn and teach math. So my background's in pure mathematics and also teaching, uh, and then I have gotten into teaching math and pedagogy and lesson plan design and training teachers, and just thinking about how all the beauty and wonder and the wonderfulness that I think so many of us know in math, how that can be accessible to kids really from as young as possible. So that's kind of my MO. That's kind of a large scale MO. Uh, we also make games. Um, so I think we have some of the few really math centric board games out there. One of them is called Prime Climb. I don't know if that's one you've ever heard of. It's a prime number based math game, and the other one is called Tiny Polka Dot, which is like a math enriched card deck for young kids, 3 to 8 years old, uh, and
Wow.
really just designed to get kids playing with math from a very young age and continuing to do so.
That sounds like a lot of fun and a really good mission. So what do you have to share with us today? And also, I'm sure many people would be interested if you have a place to potentially get those games, if you're willing to share
Uh-huh.
that.
I see Julia
Yes,
coming in.
Okay. Hi. All right. So I'm gonna let Julie take over now that she's fixed her issues. So I'm gonna sign off. Bye.
Awesome. It's good talking to you, Sydney. Hi,
all right.
Julia.
Thanks very much, Sydney. Hi, Dan. I feel like I'm still getting the hang of all of this technology. I just had a laptop breakdown, so I'm on a second laptop. I can't
Wow.
tell what's being streamed to YouTube, what I can see on Zoom. So hopefully we'll figure this all out, and I'll
I
get
think
on to
it's all
behind the
working out.
scenes
This is
stuff
a
or have
classic
this
for the
sorted.
4:30 a.m. spot, even though neither of
Well,
it's
but I have no
not that time
excuse
for
now
either of
because
us.
it's midday for me, so I have no excuse. I'm
Yep.
based
And
in Perth, Australia, so it's middle of the day here. And Dan, you're
and
in
9:30 p.m.
Seattle,
here.
right? Yeah, so
Yeah,
we both should be awake compared to all of the poor people in the UK.
that's
So
right.
welcome, Dan. It's
Yeah.
really exciting to have you on the show today. I was looking at your TED Talk yesterday. So 5 principles of extraordinary maths teaching. So maybe tell us
Yeah.
a bit about what you do and what inspires you every
Yeah.
day to do maths.
I just gave a kind of 30-second intro of myself to Sydney. But
Okay.
but no worries. I'm the founder of a math education organization called Math for Love, and we're at mathforlove.com. And then we're basically doing outreach through consulting for teachers, curriculum design, um, board game creation, and really anything that we can do that will help, especially kids, teachers, families, but really anyone get in touch with what is beautiful and wonderful about mathematics. We're kind of interested in doing that. And sometimes we'll do just totally weird experimental things. I consider this to be something like that, actually. We hosted a math art exhibit in Seattle a few years ago. Like there's just, I think just anything that is some way to share what math can feel like, what it can be. We're interested in doing that and making it happen.
Absolutely, because I think maybe as professional mathematicians, we have a different sense of doing mathematics than you might get as you were going through high school or something like that.
And
You say
I
the kind
and
of
yeah,
creativity and the beauty and the, that side of
yeah.
maths more than just doing the calculations.
And I don't know if you had this experience, Julia, but for me there was a moment when I got to see the beautiful stuff. And I remember my sense was, well, why didn't anyone tell me about this earlier? And
Absolutely.
so I think there's that, the excitement getting to share the beautiful stuff earlier too is really, I like that opportunity a lot, for sure.
Absolutely, which is why it's so fantastic that you are on the show today. So for anyone who's just joined, this is the 24-hour Maths and Magic show, and it's in collaboration with Mark Watson's What's On-a-thon, where you can be donating money to charity to raise money for people who have been disadvantaged by COVID, who are in low income situations and need a bit of help getting on with life at the moment. So I'll put up some links later. And so now, Dan, are you going to show us a magic trick?
I am, but before I get started, I need to ask the people who are watching this on the YouTube feed and who can enter in the chat. I would like you to type in a 2-digit or a 3-digit number. And Julie, I'm going to ask you to pick 2 of these numbers as soon as they start rolling in.
Right.
And let me say, I do encourage people to make these as strange as possible. So whatever if you feel like here's a really weird, unexpected 3-digit number, an unexpected 2-digit number, make them as strange as you can, as strange as you want. And Julie, feel free to pick whichever ones speak
there are already
to you.
lots of numbers coming in on the YouTube feed. So you want either a 2-digit number or a 3-digit number.
And I want 2, and you can do either. So anything between 10 and 999, you can pick 2 numbers. I will say, write them down. Yeah, write them down, because you're going to want to have these.
Write them down. Okay, I'm going to have a look.
And if anything goes wrong,
YouTube feed, and we'll pick some interesting numbers. Okay, so I'm picking them completely at random. So if I don't pick your number, please don't feel that I've not chosen you for any reason. There are lots of numbers that are the same number, so you can kind
interesting. Now that's fascinating.
People's reasoning.
And there's something about this, right?
2 numbers.
So maybe right, and this sort of gets to exactly what I was thinking about, which is I've been very interested in magic recently, and I don't do a lot of magic in my life. I'm really a mathematician, a math educator is who I am. But I've been watching the television show Penn and Teller's Fool Us. And I've just been very fascinated by how magic works and where the opportunities for the tricks are and what's possible. And there's something about the unlikely thing happening. When I was a young kid, I remember my grandma was a very wonderful piano player, and I would watch her play the piano from a very young age. This is probably one of my earliest memories, actually. I must have been 3 or 4. And I had the idea, she looks like she's just hitting the keys at random. I should be able to go do that, and maybe I'll just get lucky. And there is, a mathematical principle here, which is if you have enough chances, there's sort of a monkeys typing on typewriters will eventually type Shakespeare. It just takes a ridiculous amount of time. And in the same way, if I just had enough chances to guess your card, I could do it. What's impressive is that people get it on the first try.
Right.
Now, so this led me to want to do something that would be related to that sense of difficulty, that sense of like, oh, it's kind of a difficult odds. And it involves creating a big number. And I'd like to do that with you right now, Julia. And everyone at home, you can do this also. You will need a calculator to do this. But if you have a calculator on your computer or on your phone, I'll punch one up on my phone just to kind of. So I've got mine ready.
So can you see my calculator now? I think I'm.
Yes, I can see your calculator. Looks great.
I think the YouTube feed might take a little while to catch up.
So I'm gonna watch the first, and I'm gonna try to not see the second one. But let me just see. So your first number, what was it?
457.
457. Okay, so go ahead and type in 457. And before you do anything else, we're going to want to now extend this, because I want these numbers to actually be a little bit larger. So 457. So go ahead and extend that out to be a 6-digit number. And the way I'd like you to do that is just repeat the digits until you hit 6 digits. So 457, 457. Great, 457,457. I'm going to shut my eyes before you put the next number in, but I want you to hit the multiply button. So you're going to multiply this, and then whatever your next is your next number 2-digit or 3-digit?
2-digit.
It's 2-digit. Okay, so you've got a 2-digit number coming up. So if it were, I don't know, like 18, you would write 181818. So you just extend it, repeat it until you get to 6 digits long. So
Okay,
I'm not looking. I'm not going to see it. So you've got it. And now you can hit equals. We'll multiply these two numbers together. So we're multiplying
That's
these
a
two.
big number.
Okay, you've got it?
I have. Bear in mind that if you open your eyes, the calculator on my computer tells
no,
you
it tells me.
what the
that's
two
okay.
original numbers were. I don't know how to cover that up.
Okay, well, that's okay. In this case, it doesn't actually affect the trick too much, but that's okay. In any case, we have a huge number here. And I'm going to just jot this down for a minute. So this is, and we are in the billions, if I'm not mistaken here. So this is 258,763,296,792. I'm just jotting that down, though really I can look at the screen. Everybody else go ahead and confirm that you did this. Also, you can do this on your calculator. Now, here's the problem that I'm setting myself to. And this is something that I feel like this is a risky thing to do. But the thing about chance is that it connects very nicely with divisibility, in the sense that if you picked a card from a card deck and I were to pull it out of the card deck and I got it totally at random, if I just picked a card out of the card deck and it happened to be yours, I have a 1 in 52 chance of getting that one right. Similarly, if I were to claim that your number, and I'm not claiming this, but if I were to claim that this number were divisible by 52, and I didn't know what the number was at all, and I hadn't looked at it at all, I would have a 1 in 52 chance also, because, that's sort of how divisibility works. Our whole cryptography system is based on certain large numbers, and really just it's based on creating certain large numbers that are very difficult to pull apart, very difficult to say what factors here this large number. How do you unmultiply this? How can I take a number and divide it out and have it come out whole, not leave any decimal remainder? And if anyone just tries saying, oh, I'm going to just divide this by something, it will probably leave a decimal remainder. We've all had that experience of plugging that in. What I'm going to try to do, this is tricky, 258 billion. So the funny thing about it is, though, really large numbers, it's impossible. Small numbers, it's easy. Like, everyone knows this is divisible by 2 because it ends in a.
I was about to make that prediction. You've already beaten me to it, but now
so I could say this is
if I say that.
That's right. I could say your number is divisible by 2. No one would be impressed by that. We could all tell that.
It's also
so what I'm going
not
to try to do is
by
do
10.
something.
You can make that prediction as well.
Right. So what I'm going to try to do is I'm going to pick something that is appropriately impressive. So it's harder than just, divisible by 2, but I can't do the impossible ones that involve like digits, hundreds, numbers hundreds of digits long. So what I'm going to try to do is I'm going to pick 3-digit numbers that divide into this number. I'm going to see if I can do it.
That will be impressive.
Yeah, it's 258 billion. I just wrote it down over here. Okay, 3-digit, 200. Okay, and this is something that I feel like it takes a lot of brain power to get this kind of to work out, but I'm hopeful that it will. Okay, could you hit divided?
Not put any spoilers in the YouTube comments. Like, if you've seen tricks like this before, make sure you don't spoil it if anybody else by explaining how the trick works.
So let's go ahead and say divided by, and I'm going to give you the first number to divide by. I'm going for a 3-digit number here. Let's divide it by, let's go for 143. 143. Let's see. And now, before you hit equals, I have if I just pick this at random, I have a 1 in 143 chance that it will, work. And the other 142 out of 143 chances, we should get a decimal string. Let's see what happens.
Okay, I will be 1 out of 143 times impressed if this is correct. So, okay. Drum roll. Yay! No
Hey, all
remainder.
right.
Look at that. Look at
No
that.
remainder.
What are
1
the
billion. Let me
chances?
write that down. 1,809,000. Sorry, 809,533,544. Okay, I'm not done yet. I think I can get another 3-digit number that divides into this.
The trick does
And I'm
get
gonna
less impressive the smaller the numbers
It
get.
gets,
though.
it's
You
true.
realize
It's less
that.
impressive. So to make up for it, I'll try to make the 3-digit numbers themselves get larger. So
Okay.
Okay. Let's go ahead and say divided by. Is always scary because like you make one little mistake and it doesn't come out. Let's try 200.
It's true. The audience won't forgive you if you get this wrong.
That's right. Let's try 259 for this one.
259. That's correct.
That's correct.
100% sure. 100%.
I'm never 100% sure. Let's try it.
Dun, dun, dun.
1 in 259.
Yes.
All right.
Hey, it worked. I'm feeling impressed. I hope the audience is feeling impressed.
986,000.
259. That is a random number. Like that doesn't look like any
well, you have to
standard
really
thing you want to divide by.
Yeah, this is and again, this is based on some pretty there's just you got to really kind of be able to look between the numbers, I guess, and see how this comes together. I think I can get one more out of this.
Oh, okay. So we're down to like 6.9 million.
And I should be better at it because these are smaller numbers now. All right, last one. Divided by 273.
273. Okay. Also, I've cut a random 3-digit number. Like that doesn't look
Yeah.
like a standard divisibility. Normally we do like divisibility by 3 or 11.
Right. That's right. I'm avoiding
273.
the classic like divisible by 9, divisible by 11, divisible by 3. Yeah.
All right.
That's right.
So just divide by this. You don't want to make any more predictions, anything.
Well, let's see. So this is a 1 out of 273 chance that this works, but I've actually done 3 in a row now. So to get all of these right is, I'm going to say 3-digit numbers. What is that? Like a 1 in a million chance, I want to say, to get these right.
And I should tell the audience that like Dan and I did not collaborate before this. I did not choose the numbers myself. I genuinely chose them from the YouTube feed. So it's all completely legit. I have no idea what's about to happen when I press equals.
And I will say I'm not using any computers or, you've seen my hands most of this time. I've only been using pencil and paper or pen and paper to write things down.
All right.
So let's see if this
what happens.
And
yes.
One last one.
Amazing.
That is it. All right. And
amazing. So are you going to talk to us a bit about how the trick works, or do you want to leave it as an exercise for the reader, the listener?
I feel like this is the first time I've ever done this trick, and I've been kind of thinking about it for a long time in my dream of someday getting on Penn and Teller's Fool Me with a math trick, which my wife assures me is a pipe dream. But I do think this is one that I'm not going to explain, but I can provide a hint about it. And I think that hint should be in the form of a treat. Like we were talking about doing tricks and treats. So I'm going to, maybe I'll share my screen.
I'll stop sharing mine.
Yeah. So there are some mathematical principles that I think the audience members can derive to figure out how this trick works. This is a figure-outable trick for sure. And I have a trail of breadcrumbs for you. So I'm going to go to let me see if this works. So here's my screen. So this is, do you see that?
Yes, I'm looking at your web browser.
Okay, so this is my website, Math for 11. If you go to mathfor11.com/puzzles, these are the puzzles that I've done. These are all free and just fun puzzles. This is another little, I write scripts for the TED Ed riddles, which are super fun. And this sea monster riddle right here, if you check out this sea monster riddle on my website, I'd say on the close to a spoiler for this trick and how it works. It's not everything, but it is kind of the pieces that you need to construct the whole trick. So I'm going to leave that as the treat. I think these are really fun. I think people who are tuned in to this channel, especially if you're up at 4:30 in the morning watching Math Magic Tricks, I think you'll really enjoy those riddles also. And if you look at the sea monster riddle, that is what you need to figure out how that trick worked.
Right, so you've actually given us many different treats there. So first you've given us the treat of figuring out for ourselves how the puzzle works. And I think having those aha moments in maths is some of the biggest treat that you get from the subject. But then you've also given us the treat of all of the puzzles on your website. So that's mathsforlove.com. And did you tell me you've also got the UK version, Maths for Love?
I believe I should double check that it still forwards appropriately, but I visited Australia and I got used to saying maths instead of math. Yes, it does forward. So you can write in mathsforlove.com and it
there we go. So whether you are in the US or Canada or Australia or the UK, Maths for Love or Maths for Love, and you can check out all of Dan's amazing puzzles and a bit of a hint as to how this number trick works.
The sea monster riddle will give you the hint. It's actually funny. I'm very nervous about ever giving out the answers to anything anymore because, first of all, you'd watch my talk, my TED Talk, and in that I make a big point of not giving the answer. And I once was giving a radio interview and I gave the answer to somebody when the host asked me how something worked and I explained it. And I got an irate letter from someone being like, really? I can't believe you just ruined that. Like, I can't believe you just told us the answer. Doesn't that go against everything you stand for? And so since then, I try to be scrupulous about not ruining things for people, not giving the answers away. But I think people can maybe.
Well, now you've made me remember one of the things from your TED Talk, which is talking about the game that you invented called Prime Climb. And that was one of those wonderful moments in your talk where you showed this image on the screen of a number pattern and color pattern, and you encouraged the audience to think about what the pattern was. Is that something that you want to talk about now?
Oh, I could, yeah. I unfortunately, of course, didn't bring one of my boards. I'll get that up and I'll share my screen in a minute. That it was a very interesting thing to do actually, because there's there's a sort of a struggle to when you're giving a talk like that or doing something like that. I think so many people have a kind of math phobia that if you are too quick to say, okay, think about this math problem, a lot of people are turned off and won't want to engage. And so you really it has to be a kind of coaxing to say like, oh, just consider this. And I think the implication is, I'll just tell you the right answer, don't worry. And then later. So here's this image.
Yeah.
So here are, I'm cutting it off, but these numbers go up to 100 in this chart. There's like a poster, but here are the numbers up to 40 in this particular image. And the question is, well, what would 41 look like? What would 42 look like? How could you extend this chart? What kind of patterns are going on? And in fact, this chart is actually kind of somewhat connected to that trick I just did a little bit also, in the sense of this is really a kind of map of divisibility.
I think that's just such a beautiful image. It captures so many wonderful properties of those everyday numbers that we're familiar with, but in a whole new way. And you say that this is a board game that you can go out in the shops and buy as well. Is that right?
In fact, we're going to be we've been selling in the US and in Australia and New Zealand since 2015, 2016, 2017, depending on the country, but we're actually going to be widely distributed through ThinkFun in the UK and Europe starting in 2021, which I'm really excited about actually. So check for Prime Climb if you're interested. I think it's a game that might speak to a lot of the folks who are watching right now.
That's right. I'm just checking over in the YouTube comments to see if there are any questions. If anyone has anything they'd like to ask Dan in the last 3 minutes that we're going to be online together, now's your chance to get them in. Otherwise, thank you so much, Dan, for coming on the show today. It's been really wonderful having you along.
Yeah.
You shared many different treats with us, as well as that great trick with the divisibility, and something that people can go home now and try for themselves and see if they can figure out, well, firstly, that it does work when they do it, and secondly,
Yes.
why it works. So definitely lots of amazing things for us to be thinking about. If you are in the UK, I'm aware it's 5 a.m. GMT, so good morning if you have just woken up. And I don't know, if you stayed awake all night, then I don't really know what to say to you. You probably, your brain will be fried and you will need some coffee. Someone is asking very quickly, what's your favorite Penn and Teller routine? Do you have one?
That's
I always hate when anyone asks me for my favorite thing because I can never remember.
I feel like, I mean, they've got their great routines, which I really do love. Some of the sleight of hand that Teller does, especially when he just sort of demonstrates. There's sort of the smoking a cigarette when he's not actually smoking, but it just looks like it is. But I feel like there's certain rivalries on that show where the same person will come back multiple times and sometimes fool them and sometimes won't. And I feel like, yeah, it's those people who are willing to do close-up magic with them that always kind of blows me away. I'm not gonna be able to remember the people's name, but there's somebody who's been back like 3 or 4 times, and yeah, so I'm a fan of that kind of thing.
Yeah,
So
I
not
also
maybe
have
the
a
most
huge amount of
satisfying.
respect for a real magician, because I feel like when I do mathematical magic, there's that certain confidence that the maths means it's always going to work. You don't have to do
Right.
anything special. It just, the universe is magic. Whereas when you're doing sleight of hand, and it takes so much practice and
The
commitment.
hours and hours. Of course, there were hours and hours that went into learning the math, and somewhere along the way also that was not a trivial thing either. Yeah, well, what a pleasure. Yeah, it's so fun to talk to you, Julia, and I hope you have a great
thank
time
you very
with
much, Dan. I guess it'll be bedtime for you soon over in Seattle.
It will
so
be. Yeah, I know.
wish
I get
you
to
a
go to
good
bed at a
night.
reasonable hour. Yeah.
Absolutely. All right. Thank you so much, Dan, and have a great evening over in Seattle in the US.
Thank you, Julia.